A warm welcome to this platform. So in this video, we are going to mainly focus on writing chemical equation and chemical formulae, and of course balancing the chemical equations. But before then, it's very important that we have the prerequisite information that is needed for us to understand that part. And now we are going to start with, or the information that we need is information on valence. So that is the first part that we are going to look at. So now to start with, let us define what a valence is. And of course, by definition, we are going to define a valence as the number of electrons, take note, lost, gained, or shared by an atom of an element to attain stability or to attain a stable structure. So that is how you define a valence. So which means the number of atoms, the number of electrons lost, or can be the number of electrons gained, and of course shared. Now, this definition encompasses metals and non-metals. As you know, on the periodic table, you find metals and non-metals. So now, let us get into this. How do you easily determine the valence of the element? Because that is very important when it comes to writing chemical equation. So now, we are going to generalize it in this way. So for group 1 elements, in terms of valence, they have a valence of 1. Why do they have the valence of 1? We are saying a valence is the number of electrons lost. So for metals, you know those that are found in group 1, they are metals. And for metals, they lose electrons for them to gain stability. So now, they lose 1 electron. Let me give an example of the element that is found in group 1. So one of the elements that is found in group 1 is lithium. And lithium has the atomic number of 3. So if we were to write the configuration of lithium is going to be 2, you know that in the first shell required number is the maximum number is 2 for stability. Then of course the remaining will carry to the second shell. So there are 2 shells, but the outermost shell, which is unstable, it is lost. Okay, the electron is lost. That is the characteristics of metal. They form a positive ion. In short, they lose electrons. So the number of electrons in the outermost shell is the one that is lost. So the number of electrons that is lost in the case of group 1 is 1, and therefore the valence is 1. I guess you get that point. So this means that element, if you don't want to go into that, you can just look at elements that are found in group 1. They have a valence of what? A valence of 1. All of them that are found there. So you can talk of sodium, you can talk of potassium, you can talk of lithium and other. Okay? Then those that are found in group 2 have a valence of 2. So the explanation for the first one also saves us for this one, because we are still dealing with metals. So metals lose electrons. So the number of electrons lost equal to the valence. For example, calcium. Calcium has the mass number of 40, atomic number of 20. If I were to write the configuration, is going to be 2, 8, 8, and what is remaining? A 2. So this 2 outside is lost, and therefore the valence of calcium is what? 2. Then what is the valence of those that are found in group 3? So those that are found in group 3, in the case of aluminium and other, the valence is 3. Those that are found in group 2, the valence is 4. They have a valence of 4. So this is the range where you expect to find metals. I'm not saying that in the case of group 4, we cannot generalize that all of them are metals, but we can say this is the range where you find what? Metals. From group 1 to up to 4. So these from group 1 up to 4, their valence, you just look at the group number where they belong. Those that belong to group 1, they have a valence of 1. Those that belong to group 2, they have a valence of 2. Those that belong to group 3, they have a valence of 3. And of course up to 4. Now, you've entered non-metals. Now, this is where you're likely to find non-metals. Now, for non-metals, they gain electron in order for them to be what? To be stable. In the case of those that are found in group 5, such as nitrogen, what is the valence for nitrogen? So for these starting from 5, hear me very well. Starting from 5, the valence is 8 minus what? Minus the group number. So 8, we are looking at stability in relation to group 8 elements. And then now, you subtract 5, the group number. So group 5, you subtract 8 minus the group number, which is 5. and therefore the valence for group 5 elements is 3. Then group 6, you are going to say 8 minus 6, which is 2. So this is where you find oxygen. This is where you find sulfur. Also, all those have the valence of 2. Then what about those that are found in group 7? You are still going to say 8 minus 7, and this is 1. So the valence of these that are found in group 7, they have a valence of 1. Those that are found in group 8, you can say 8 minus 8, and this is 0. So those that are found in group 8, they have a valence of 0, which means they are non-reactive. Okay, and that is the reason why sometimes they are referred to as a 0 group, because they have a valence of 0, and of course they are stable. Their outermost shell is stable. They do not undergo any reaction. And of course the valence is the one that determines a reaction, since we are saying it's a combining power. So now, the other thing that we would note is that the valence do not have any charge. So it's just a number. Now, why am I giving you in terms of group numbers and all this? Because the periodic table is given in an exam. So it is very easy for you to master this part in terms of valences in the case where you are given the reaction that involves these elements. So it will be very easy for you to go around this. So using the periodic table, you can determine this. Okay, so number of electrons gained or lost or shared. That is what determines the valence. So these are the valences. But we have those that are found in group 1, group 2, group 3, group 4, group 5, group 6, up to group 8. But we do have elements that are found between group 2 and group 3. Okay, what about those that are found between group 2 and group 3? And that is where you find what is called transition metals. Now, transition metals, as the name suggests, they are metals, just that they are found between two groups. That's why they are called transition metals. But how do you determine the groups or the valence of the transition elements? So, why are they found in that position, or why are they between group 2 and 3? So, this means because they have the varying valences. Okay, they have varying valences. Varying, which means different valences. So, varying what? Valences, depending with the reaction or the reaction they are in, or in which they are reacting. So, for example, of elements that are found or that are in the transition elements or transition metals, we have copper. So, copper depends with a reaction where you find where it is reacting, or depend with the element it is reacting with. So now, how do you determine their valence? So you are going to find always the numbers indicated in Roman numeral. For example, copper, let's say it's written copper 2 oxide. Copper 2 oxide, it means that in this case, copper has a valence of what? 2. Okay, copper 2 oxide, it means the copper has a valence of 2. So that is how the valences of these differs. What about iron? The other one that we can find there is iron. So you're going to find iron 2, iron 3, depending with the reaction. Okay, for example, iron 2 oxide. Iron 2 oxide, which means iron 2 or iron with a valence of 2 reacted with oxygen, which forms oxide. So iron 2 oxide. Iron 3, which means iron of 3 valence. So I guess you get this thing. But if we are to look at zinc, zinc has a valence of what? Of 2. Okay, so they have varying valences ranging from 2 to 3. Okay, so this is the reason why they are found there. I guess you get the point. So in the reaction where they are found, you are going to find them indicated or indicating iron 3, iron 2, which means if it's iron 2, iron has a valence of 2. And of course, you know the other one, if it's in iron oxide, the other one is oxygen, and oxygen has a valence of 2. So basically, that is what you need to understand. So having explained this thing about the valency, the other thing that we need to look at, I think, we need to look at radicals. Because this is what you're going to find generally in the reaction. So let us look at radicals. Now, equally here, we are going to start by defining what a radical is. And now by definition, a radical is just a group of atoms which is present in the what? Or in several compounds, but are incapable of what? Independent existence. Or we can say the group of atoms that are present in several compounds, but are incapable of independent existence. They cannot exist on their own, but they are a group of atoms. They are found in a compound, or that are found in a compound here. Okay, So that is how you define a radical. Now let us get to look at some examples of radicals. So examples of radicals and their valences, because what we are interested in here is at the end of the day so that we'll be able to write the chemical formula in a chemical equation. And this is the prerequisite information that is very cardinal when it comes to dealing with that part. So it's very important that you understand the basics. One of the reasons could be why you find it difficult to write the chemical formulas and chemical equation is because you do not know this part. Now, let me also emphasize that for a first part where we looked at the valences of the metals, for the valences of the metals and non-metals, that part is very easy because you can determine it using a periodic table, of which is given in an exam. But for the radicals, you just have to master them because you'll not be given. They are not found on the periodic table. So you just have to master them. And of course, it wouldn't take you even time to master everything here. I guess you get that point. So now let us look at the radicals and their valence. So one of the common radicals that you're going to find is ammonium. Now ammonium, I should indicate that this one, it has a positive on top there. So it has a charge of positive here. So ammonium has a valence of 1. So forget about this charge. When it comes to valence, you just look at it as a valence of what? Valence of 1. Equally, chlorate has a valence of what? Has a valence of 1. Then hydrogen carbonate has a valence of what? Has a valence of 1. Hydroxide has a valence of what? 1. Nitrate has a valence of what? Has a valence of 1. So these radicals that we've looked at in the first part, they have a valence of 1. Okay, so all of them have a valence of 1. So master them as we go on to write the chemical equation. They'll be very important. Then perhaps the second part, we are looking at radicals with a valence of, let us look at them. So we have this one with a valence of 2, which is carbonate. Carbonate has a valence of 2. So whichever equation or chemical formula you find carbonate, just know that you're combining there, carbonate has a valence of 2. Then oxide, which is oxygen in reacted form, it has a valence of 2. Or oxygen also has a valence of 2. Then sulfate has a valence of 2. It's a radical as well. Sulfide has a valence of 2 as well. Then phosphorus has a valence of 2. Other radicals that we can look at chloride. You know that chloride is coming from chlorine, and chlorine has a valence of 1. So please master this as we go on to write chemical formulas. They will be very important. And of course, chemical equation. You are going to discover that you just be going around these things. So you understanding this part, which means you have no problem as we go on. Okay, so let us move into writing chemical formulas. So the first part, we are going to start by looking at writing chemical formulae. Now it's very important also you understand what a chemical formula is. So a chemical formulae consists of symbols or symbol or symbols showing number of atoms in one molecule of an element or a compound. So that is basically a chemical formula. Now let us look at the actual thing now. So it's very important to we look at the steps that are involved when writing the chemical formula. So steps to consider. So the first thing, you need to write the symbol, or you need to know the symbol of the elements or radicals that are involved. So elements, we can talk of metal, magnesium, we can talk of calcium, we can talk of even non-metals, we can talk of sulfur, in short, whatever is found on the periodic table are called elements. So you need to be aware of their symbol. For example, calcium is written as Ca. Magnesium is written as Mg. Potassium is written as K. Copper is written as Cu. So this is what it means that we need to know the symbol of the elements. Then of course the radicals. Also you need to know the radicals. For example, a sulfate. You know a sulfate is like this. What else? Hydroxide, like this. So we need to know what is reacting really. So you need to know the symbol. When you are told hydroxide, should bring out the hydroxide symbol. Sulfate should bring out the sulfate symbol. Phosphate, you should bring out the phosphate symbol. So that is what it means. Okay? So now, what about the other one? Write the valence on each element or radical at the top right hand side. Okay, so we are going to see how this is done. Okay, so this is how it is done. So for this second part, we are saying write the valence of each element or radical at the top right hand side. So this is a radical symbol, which is phosphate. This part of phosphate is the left part. This is the right part. Now we are saying at the top right side, so which means here. So what is the valence of phosphate? The valence of phosphate is what? 3. Where we are coming from? Did we look at it? So here we have those that have a valence of 2, and of course the one that has a valence of 3, which is just phosphate. So phosphate is the one that we can look at that as a valence of 3 in terms of radicals at a moment. Okay, so what it means, writing at the top right hand side, it means that on top here, on the right part, like I've said, this is the right, this is the left. So on top here, and also this one we can write the valence here. Also this one we can write there. You write it as a superscript. Okay. Then what is the third step? Exchange the valences. Exchange the valences of the combining elements and radicals or radicals by writing them at the bottom right hand side of the element or radical. So this time around you exchange them, and of course you write them at the bottom right. So phosphate, the bottom, this is the left, this is the right. So the bottom right is this part. So this is where you are going to write when you exchange it. But of course, we are going to see how it is done. So these are the 3 steps that you need to know for you to write the chemical formulae successfully. Aside from this, there's nothing else. So all what you need to do is to have these steps in mind, not necessarily writing each step as you are writing, no, but these are easy to master in your mind. It's supposed to be in your brain. As you write, you consider the first step. Okay, you know this. When you know the steps, I can assure you that you're not going to have a problem. You're going to write the chemical formulae within some milliseconds just by looking at the steps. Okay, so now let us get into the actual thing now. We have examples here. We want to write the chemical formulae. So we are going to start with the first one, magnesium oxide. Let us look at magnesium oxide. Let us go. What is the first step? Write the symbol for the combining elements or radicals. Let us look at it. Magnesium oxide. So what are the combining elements here? Or if at all radicals, if they are there. What are the combining elements? Magnesium, you breathe, oxide. Oxide we said is what? Oxygen. Magnesium is an element, it's a metal. So now, we know that magnesium is Mg. Then next to it we write oxygen. Just write O, just like this. You just write O. Okay, don't write O2, just write O, oxygen. Then what is the second step? Write the valence of each element or radical at the top right hand side. Since these are elements, so we're going to write what is the valence of magnesium. Check from your periodic table. The valence of magnesium is 2 because magnesium is found in the second group on the periodic table. Remember that information, don't forget. So the valence is just a number, not a charge. Without a charge, I mean. So you're going to write on top right here, write a 2. Then what about oxygen? Oxygen is found in group 6. What did we say? 8 minus 6. The valence is also a 2. We've written it. So this is it. The first step, we know the symbols. Or let me just put them like this. So the second step, O, then we write the valence like this. Then what is the third step? The third step, we swap them. Okay? Swap them. So which means this one goes at the bottom right here. This goes at the bottom right here. Not here, but not here. Not this part, not this part, but the other part. So we need to swap them. What are we going to have? We are going to have Mg, a 2. We write it as a subscript. Okay? Then O, then a 2. This is magnesium oxide. Now, you know that these are ratios of atoms that we have here. So we have 2, 2, 2. This one can be reduced to 1 to 1, which just means that is MgO. So MgO. This is the final chemical formula. So all these steps, because we are learning, but immediately we understand we master the parts, and of course we understand everything. It is just an easy process. I'm just showing you all the steps for the sake of what? Learning. So this is magnesium oxide. So we can safely say magnesium oxide is MgO. Okay, so that is magnesium oxide. Let us look at the second one, calcium sulfate. Now, we are not going to go back to look at the steps. We are going to try and master them here. So let me just try to reduce this one. So for the first one, magnesium oxide. And please don't write M like this and G. Magnesium, M is a capital letter, then O, also something like that. Then calcium sulfate. Calcium sulfate, what about calcium? So the first thing, we know the what? The symbol or symbols for the elemental are radicals. Now, calcium, you breathe, sulfate. So which means in this one there's calcium. Calcium is written as Ca. Then next to it we are going to write sulfate. Sulfate is a radical, is written as CO4. Like this. Then the second step, what is the second step? We write their valence on top right side as superscript. So we're going to write the valence for calcium is found in group 2. So it's a 2. Sulfate is a radical, it has a valence of what? 2. Then what is the next one? We swap these. So this one is going to come right here. This one is going to go right there. Now, without you struggling, if the numbers are the same or the valences are the same, just leave them out. If the valences are the same, just know that it's a 1 to 1. So this one can be written as calcium, then sulfate. So it's written like this. Okay? Alright. So that is calcium sulfate. As simple as that. So, calcium sulfate. Then what about sodium chloride? So, sodium, you breathe, chloride. So, sodium is a metal written as let me just push it here, Na. Then chloride is a chlorine. Okay, chloride, chlorine. So, chlorine. What is the first step? We've know the symbols. Then what about the valence? Sodium has a valence of 1. It's found in group 1. Chlorine is found in group 7. So 8 minus 7 has also a valence of what? 1. Valence are not charges, just write numbers. Then we swap them. This one will be written there. And this one will be written there. So 1 to 1. This is the sodium chloride. That is how you write it. So that is the sodium chloride. I hope you are following up to this point. So sodium chloride. Let us look at aluminium sulfate. So aluminium and sulfate. So aluminium is Al and sulfate, or phosphate I mean. Aluminium is Al, but phosphate is PO4. That is phosphate. Now, if you were to look at aluminium, aluminium is found in group 3. So it has a valence of what? 3. Then phosphate also has a valence of what? 3. So now, what do? You swap them. You swap them. So they are the same. So you're going to have aluminium phosphate. Like this. This is aluminium phosphate. Okay, so aluminium phosphate, just like that. So aluminium phosphate. Then 5, calcium hydrogen carbonate. Calcium hydrogen carbonate. So we have calcium. You never have 3, please. You never have 3. Okay, so which means when you mention calcium, just know that the other one is attached. So hydrogen carbonate. Hydrogen carbonate is written as like this. What did we say is the valence where we are coming from? There, hydrogen carbonate has a valence of 1. So calcium has a valence of 2. Hydrogen carbonate has a valence of 1. So now, here you need to pay particular attention. We have a new thing. the valences are not the same. So what you do? If the valences are not the same, we are going to go through the process of swapping. So this 2 will go there, and this 1 will go there. The 1 will change nothing. So this one is going to be calcium. But these 2 here, we cannot put a 2 there. What do? We cannot put a 2 there because of this number here. So what we do, we put this in brackets before we put a 2. So we put hydrogen carbonate in brackets, then we add the 2. So this is calcium hydrogen carbonate. I guess you are following. It's getting interesting, right? Let us continue. So calcium hydrogen carbonate, written like this. Then of course, let us look at the other one, ammonium chloride. Ammonium chloride. Now, where we are coming from, a radical ammonium is written like this, and it has a valence of 1. And chloride, written like this, has a valence of 1. So we can close this and close that. So, ammonium chloride, written like this. So please, it is not, don't make a mistake of bringing this one here. It goes on the right hand side. This is left, this is right. So it has to be here. So pay attention to that. Okay, those are simple mistakes that you might encounter or you might make. So ammonium chloride. Then what about ammonium sulfate? Ammonium sulfate. So ammonium and sulfate. So ammonium is H4. Then sulfate is S4. Or phosphate, I mean, is phosphate. Phosphate. So has a valence of 3, has a valence of 1. So what are you going to do? You're going to swap these. This one will come here. There one will come here. Now, since we have a number here, we cannot put a 3 here. You are going to put this one in bracket. So it's going to be like this. Ammonium. Then outside, what is the number? Phosphate. Then of course you're going to have what? PO4. So this is ammonium what? Ammonium phosphate. Okay. Now, let me also maybe just give you something. Let me say, which other one can I think of? The one that has to reduce. Okay, so let me just give maybe element X has the valence of 4, or let me give carbon dioxide. Okay, let me give carbon dioxide. It will be a perfect example. So I said ammonium phosphate, like this. Let me give an example of carbon dioxide. Carbon dioxide. I want you to see something. So for carbon dioxide, you know that is carbon and what? And oxygen. Now, carbon has a valence of 4. Oxygen has a valence of 2. So you're going to swap these. 4 will go there and 2 will come here. So you're going to have C2O4. If carbon dioxide, you write it like this, it is correct. But mathematically, you know that you need to reduce these ratios. So you need to divide 2. So because there's a number that can go into 4 and 2. So reducing this one, that's why it becomes carbon, then oxide, like this. So if you have the numbers that can divide here, they are not the same, but you have something that can be reduced, you have to reduce. For example, if you have, let's say, X6, then Y4. This one can be reduced to 2 can go into there, 2 can go into there. This becomes X3, then Y2. So that is the final one. Okay, I hope you understand that. Alright, so that is basically that you need to know about chemical formulae. Okay, so perhaps now we've built from this, we can look at now chemical equation and of course balancing. We'll spend quite some time there, but there's nothing really to, since we've done much of the work, what remains is just something that we go through quick. So let us look at chemical equations. Okay, so for chemical equation, again, before we even get into it, because what you're going to find, the questions that you're going to find is write the balanced chemical equation with state symbols. So it is very important for us to build from state symbols. So how do you write the state symbols? How do you determine the state symbols? So the 4 state symbols that you're going to come across is gas, liquid, solid, and aqueous. What is the state symbol? These are just letters that are used to show the physical state of a substance in the equation. So you putting the state symbol, you're showing the physical state of the substance. You know that they can be gas, liquid, and solid. And of course we have the one that is the aqueous. Let me start with gas. So gas, you're going to find that most of the non-metals are gas. Talk of oxygen, talk of hydrogens and all those. Most of the non-metals are gases. Group 6 element, group 7 elements, most of them are in what? Are in gas form. So I've given you a clue of what you're going to put as a gas. Okay? Then now, liquid, we are looking at, you can find water. Water is in what? Liquid form. So one of the substances that is in liquid form is water. Then for solid, we are talking of metals. Most of the metals are in what? Solid form. So that is what you need to know. Then aqueous state, we are looking at when you are dealing with now acids, when you are dealing with bases, most of the base, sodium, I mean hydroxides, bases that are hydroxide, because a base can be an oxide, metal oxide, or hydroxide. So most of these hydroxide are what? Are in aqueous state. Okay? Then the other aqueous state that you can find also, you should be able to know. In short, the aqueous state or aqueous solution is just a solution in which water is a solvent. So anything that is dissolved in water becomes aqueous state. But also you should know that when aqueous state or aqueous and solid react, they form aqueous. The resulting is aqueous. Okay? A gas and aqueous, of course, the resulting is what? Aqueous. So aqueous always stand out. It becomes the overall in terms of the state or the physical state. And I guess you get that. Okay, so having looked at the state symbols, let us have a look at something. And we are starting now the actual thing, that is chemical equation. Now, again, it's very important for us to define an equation. So if you are going to talk of an equation, we are going to say an equation is just a chemical sentence which describes what is happening in a chemical reaction. So now, when you react, for example, acid plus what? Plus metal. Okay? In terms of chemistry, for you to put it in chemical sentence, you are going to have to use symbols. So that is just an expression of a reaction in terms of symbols. That is a chemical equation. There's also what we call the word equation. For the word equation, you just write everything in words. The chemicals, the metals, and all that, you write them in what? In words, in their names. Okay? But for chemical, you go into symbols, as we are going to go into that soon. Now, a general reaction in terms of equation, let us generalize it. Let us say reactant A, of which we are not sure of the name, react with B to form what? C and D. These are called reactants, and these are called what? Products. So very important to understand. You have the reactants and what? Product. Now, how is this reaction read? So very important again. It's very important. So how do you read these symbols that you find here in this general reaction, please? We can see there's a positive here. Again, there's a positive here. Again, there's this arrow. How do you read this? So, why I'm saying, why we want to look at how you read this, because that is what you're going to find in the what? In the questions, and you have to interpret what it means. So here, this one can be read as A react with B. So this first positive is react with. Okay, the first positive is react with. So this first positive is react with. So A react with B. Then this is to form. To form. So when you find in the sentence to form, just know that you are putting now this R. Then this is and. This second positive is and. So this one can read it as A react with B to form C and D. I guess you get that. That is how you look at this. And this is a simple concept that you need to understand for you to know how to write the equation. Because you are going to know how to separate the what? The symbols, I mean the equation. You are going to separate, you are going to know how to separate, or which one is the reactant and which one are the products. So this is where most of you miss it. So A react with B in general to form C and D. Let us get into the example. So the first example that we are looking at is magnesium ribbon react with oxygen to form magnesium oxide. So react with here, you know that is plus, then to form, you know that is the arrow, and now you have the product. So in terms of writing here in word equations, we are going to say magnesium, this is word equation, not chemical equation. Magnesium, okay, magnesium react with oxygen, we are writing the word equation, to form magnesium oxide, something like this. So this is the word equation. This is what this mean. Now from the word equation, let us have the chemical equation. So now we've started finding the what? The solution. So we are going to start with the first one. We said magnesium plus oxygen, or react with oxygen. And now we are going to form what? Magnesium oxide. Okay? This is the word equation. Now, in terms of chemical equation, how do you write it? This is where you need to be very careful. What is reacting? What is reacting is So, to write the chemical equation, also there are steps. To write the chemical equation, there are steps. The first thing, you need to know the symbols for the reactant that are reacting, be it the compound or the elements. So you need to know their symbols. And symbols are derived from the chemical formulae. So here everything you are going to build from the chemical formulae. Okay, as we are going to see. So magnesium, the formula for magnesium, what did we say? So don't worry when you find magnesium ribbon. Okay, some of you are going to look for magnesium ribbon on the periodic table. You will not find it. Instead, it's just magnesium. So magnesium is Mg. Then react with, and the symbol for magnesium is a metal, it's a solid. Then react with what? React with oxygen. Now here in the reaction, you are not going to write just O, you are going to write O2 because it's a gas. So what is going to form? So you're going to put the symbol for to form. What is going to form? Magnesium oxide. Now this is the chemical formula in word. How are we going to write it in terms of symbols? Okay, so we've learned about chemical formula. So magnesium oxide, how do we write it? What is involved in magnesium oxide is magnesium and what? And oxygen. Valence 2, valence 2. And therefore magnesium oxide is written as MgO. And of course this one, solid and gas reacting, the resulting is what? Solid. Okay? So magnesium is a solid. Okay? So this is what is going to form. So is this equation balanced? Is it balanced? So we need to balance it. Here we are writing the balanced chemical equation. Now, I've brought in the other concept of balancing the equation. Balancing the equation, you are just taking into account the atoms on the reactant and of course on the product. They should be equal. They should not be loss of atoms or something. They should balance. That is what it means, balance. Now, for you to ascertain now the number of atoms, or for you to know or to be sure that the atoms are balanced, you are going to identify the atoms that are involved on the reactant. And that is what you're going to find on the product. So on the reactant side here you have magnesium and what? And oxygen. Don't write how many are they, or don't write O2. Just write oxygen and you're going to write the numbers. How many are they now? So here magnesium is 1. And of course here oxygen is what? 2. This side, if you want to look at, also you have magnesium. So what you have this side is what you have the other side. So you have magnesium and oxygen. Oxygen this side is what? Oxygen is 1. Then magnesium is what? Magnesium is 1 as well. So we have magnesium is balanced, but we have a problem with oxygen. So what are we going to do to make this oxygen 2? So please, to balance the equation, you don't put a 2 here. The 2 you put in front of the compound. So I'm going to put a 2 here. So putting a 2 here, this 2 multiplies everything. Magnesium 2, oxygen 2. So which means magnesium here has become what? Has become 2. Then oxygen here is what? Is 2. But we have a problem here. Magnesium is 1. So we need to make this 2. So we're going to add a 2 in front. Okay, so this one becomes 2. So this is the balanced equation. So that is how you balance it. So I'm not saying you write all these. These you can use a pencil if you are learning how to do this. But of course you can just put numbers, you try out numbers, because this is a game of try and error. It doesn't mean that the 2's here, I just went direct and of course I knew the numbers. You are going to have to try numbers and of course you keep on changing. You put this number, it changes everything. You check and of course until you find the numbers to put. That is how you're going to work it out. So this is the equation we've written it successfully. Then the second equation is that sodium hydroxide react with dilute acid to form a salt and water. Now, can I also bring out something here? When it comes to writing equations, chemical equations, there are only 3 things that you are going to find involved. 1, a metal reacting with what? With acid. And this one generally gives you what? Salt and what? Hydrogen gas. That is what you're going to generally find. Okay, most of the equation you're going to find the metal was reacting with an acid. What was formed now? What is formed is a salt and hydrogen. Or you're going to find a metal, that is a base, acid and base. Acid reacting with what? A base. And this is called the neutralization reaction. What is formed is salt plus H2O, water only. Then of course the third one, you are going to find acid plus a carbonate. Okay? And what is formed here is carbon dioxide, water, and of course what? A salt. So these are the general reaction that you are going to find. So acid, base, and salt, really need to go through that. So this is what you are going to deal with as we go on to look at the equation mostly. But of course here we have another one for magnesium or a metal and oxygen forming a metal oxide. Back to the question, let us look at the equation. So sodium hydroxide react with hydrochloric acid to form salt and water. So we are saying sodium hydroxide. I'm not saying that every time you start by writing the word equation, but it's very important. React with what? Did we say hydrochloric acid? Hydrochloric acid. What is formed? Salt and what? And water. So now, it's very important. What is sodium hydroxide? What is the... since we are saying the first step in writing a chemical equation, we need to know the symbols. So, what is reacting here? You know that sodium hydroxide and hydrochloric acid. So, sodium hydroxide, how do we write the chemical formulae for sodium hydroxide? So, sodium and hydroxide. So, we have sodium and what? Hydroxide. This has a valence of 1, this has a valence of 1. So, which means this one is just going to be sodium hydroxide. So, I'm not saying you show all this, but you need to know where it is coming from. So, we are writing the chemical equation now. So, sodium hydroxide. Okay, now I said any hydroxide is a base and of course it's an aqueous state. So, this is aqueous. Okay, then reacting with what? Hydrochloric acid, which is an acid. So, hydrochloric acid is written as HCl. Now, at this point, let me also guide. You need to know 4 strong acids to be on the safe side and their chemical formulae. What are the 4 strong acids? Nitric acid. You need to know sulfuric acid. You need to know that is hydrochloric acid. Okay, so the other strong acid that you need to know is phosphoric acid, written as HC3. Okay, written as this PO4, phosphoric acid. So these you need to know them by heart because you are going to commonly find these. Okay, so here sodium hydroxide react with what? These are strong acid, by the way. Or these. Then now what is going to form? A salt. Now, if you find a base reacting with an acid, what is formed is a salt and water. Okay, it's a neutralization. The kind of reaction, in the case you are asked, what kind of reaction? It's a neutralization reaction. Now, what happened here? listen to this. You know that what forms is salt and water. So you need to know where is the water coming from and where all the salt. What is the name of the salt? So look at this. The sodium in a metal, the sodium in a hydroxide displaces the hydrogen in an acid. So this hydrogen will be displaced. To be displaced is to be pushed out, and this hydrogen is going to react with this hydroxide and to form water, H2O. This one is going to react with chlorine, so it will be sodium and what? Chlorine. And you know what is formed? Sodium chloride, then plus H2O. And all this displacement reaction, the other explanation that we can give is because sodium in the reactivity series is above compared to hydrogen. So therefore, it displaces the less reactive elements here, which is hydrogen. Okay? That is how you can look at it. Okay? So very important to understand that. And you know that a salt is a compound that is formed when the positive ion from the what? The base react with a negative ion from the what? From the acid. So just that itself is able to what? To tell you something. Or how you can look at it, this one, is that you can try and split this one. You say sodium and hydroxide here. And of course, this is hydrogen and chlorine. So this part that is inside react, and what is outside react. I think that is easy. And now this one you can only look at it when you start with a base. So when you start with an acid, I don't think that one will apply. So to maybe strategically to use this strategy, start with a base, then end with the acid. Then you can claim or can use this strategy where the inside part react and of course the outside part react. Okay, so that is how you look at it. Now, is this equation balanced? So we've just put this one as aqua state. What about the HCl? All the acids that are used in the laboratory, they are in aqua state because they are diluted. So acid is in aqua state. So all these in aqua state because we use them in diluted form. We add some water. Then of course, sodium hydroxide, sodium chloride, aqueous and aqueous is reacting. So this one we expect it in what? Aqueous. But of course, water we said is liquid. So now, is this equation balanced? Let us check. So what are the atoms that are involved in the on the reactant side? So we have sodium, we have oxygen, and we have hydrogen, and of course chlorine. Then also this side, that is what we have: sodium, oxygen, hydrogen, and chlorine. So they need to balance. How many are the sodiums do we have this side? So for sodium we have 1. What about the oxygen? We have only 1. Then what about the hydrogens? We have 1, 2. So hydrogens we have what? 2. Chlorine we only have 1. Let us check the other side. How many sodium? We have 1. Oxygen we have 1. Then what about hydrogens? We have 2. Then what about chlorine? We have 1. So this equation is balanced on its own. So this equation is balanced. Okay? This is how you write the balanced chemical equation. Now, before we go to the other equation, let me just maybe here also bring in the concept of writing ionic equation. How do you write ionic or net ionic equation? Okay? How do you write net ionic equation? So net ionic equation, how do you write them? So for net ionic equation, you are just going to show the ions. Now what happened? When you are writing the net ionic equation, always those that are in aqueous, they split. So those that are in aqueous state in the equation that you've written, split. If you are not given the equation, you're going to start first by writing the equation, balance it. And now you need to know that those that are in aqueous state, they split, okay, into their individual ions. Okay, so what are the ions that are found in sodium hydroxide? So the ions that are found here is sodium, positive ion, then hydroxide, negative ion. Okay, all these are what? Aqueous, aqueous. Then plus in hydroxide, acid, hydrochloric acid, we find hydrogen ion, and of course what? Chlorine ion. All these we can say they are in aqueous. They are in aqueous. So plus. Then now on the other side, we split those that are in aqueous. So sodium chloride, we're going to split it. So sodium positive plus chlorine negative. So aqueous, aqueous. Okay, then plus water. We are not going to split it because it's in liquid form. Solid, liquid, and these other states you don't split. You only split those that are in aqueous. Okay? Then now, in order to write the net ionic equation, you are going to cancel out what we call spectator ions. And those are the ions that are found on both sides of the equation. That is on the reactant and of course the product side. Now let us check. Do we have sodium here? We have here. Do we have sodium here? Yes. So sodium and sodium cancels. Do we have hydroxide here? Yes. Do we have hydrogen? Do we have hydroxide here? No. We leave it out. Do we have hydrogen here? Yes. Do we have hydrogen there? No. Do we have chlorine? Yes. Chlorine? Yes. So chlorine cancels. Then now, what remains here? You are going to remain with sodium hydroxide plus, this one is negative, sodium hydroxide plus hydrogen ion. Then what is going to form? H2O. So this is liquid, this is aqueous, this is aqueous. So this is the net ionic equation. Okay, that is how you write it. So split the aqueous, cancel out spectator ions, then whatever remains, just write them just like that. Okay, so we have this third question that we need to answer. So I can clean this part for the third question. So the third question is calcium carbonate react with dilute sulfuric acid. Calcium carbonate. So please, these reactions, you need to know the product even before you write the equation. So immediately you hear a metal reacting with an acid, just know that what you are going to produce is a salt and hydrogen gas. But when you hear of a base, a hydroxide base or metal hydroxide base, just know that what you are going to produce is what? Also salt and water. Then of course a carbonate, you produce salt, carbon dioxide and water. So let us look at this one. Calcium carbonate, so you can say calcium carbonate react with, so plus dilute hydrochloric acid. So don't write dilute, it's just sulfuric acid. Dilute, they're just telling you that they added some water. So sulfuric acid. Then what is going to form? Calcium. They even told you that calcium sulfate. Then plus what? Plus a gas, which is carbon dioxide, you know. Carbon dioxide. Then plus what? Plus water. So this is the word equation. So the word equation, you need to have it at the back of your mind for you to write the chemical equation. So now let us look at the chemical equation. What did we say? You need to know the symbol for this compound in terms of chemical formula. So calcium and carbonate is reacting. So calcium and of course what? Carbonate. Okay. Carbonate from the radicals has a valence of 2 and calcium 2. So calcium carbonate is written as this. Okay. Which is in solid form. Then plus sulfuric acid. You remember what I told you about the acid? So sulfuric acid is written like this. Then what is going to form? Calcium sulfide. Now how is calcium sulfate going to be? So it's calcium and what? Sulfate. So they have valence 2, calcium sulfate written like this. Then of course what is the other one? Carbon dioxide. So plus carbon dioxide plus H2O. This is liquid. This is gas. This is what? This is aqueous. The acid is aqueous. And this is solid. So now, is this equation balanced? Let us check. So what do we have here? Calcium, carbon, oxygen, then hydrogen, and sulfate. Okay? Then what we have here equally? Calcium, carbon, oxygen, hydrogen, and what? And sulfate. So how many are the calcium here? If we are to check, only 1. How many are the carbons? Only 1. How many are the oxygen? 3 plus these 4. It's giving us how many? 7. How many are the hydrogens? 2. Only 2. How many are the calcium here? Only 1. How many are the carbon? Only 1. This carbon here. How many are the oxygens? 2. Then this 6. That is 7. So oxygen, there are 7. How many are the hydrogens? Hydrogens are how many? 2 hydrogens. Okay. So 7, 7, 2. I guess even this one is balanced. So if it wasn't balanced, would have gone to balance it. Okay. So that is very important to know. So please, that is something that you need to know. Okay. So that is it about chemical formulae, chemical equation. That is something that you needed to know. So please know how to write the chemical formulae first, chemical equation, balance them, net ionic equation to do, or that is what you needed to know. So thank you very much, and of course go through if the information, if you're going to understand the thing, and don't forget to subscribe, invite more to this channel, and let us learn together. But I'll give you a week where you're going to look at some more in terms of net ionic equation. So look at how to split all those and you'll be okay. So thank you very much and see you next time.